Hi and welcome everybody. My name is Jachim Coudenys and I work for a Belgian hosting company which is also active in the Netherlands, which is called Combel. So today we're going to talk about writing history by keeping a diary. So who here is keeping a diary? Nobody ever admits of keeping a diary, but it's a very common practice to keeping a diary. But first, let's see what a diary really is. So, according to Wikipedia, a diary is a record with discrete entries arranged by date, reporting on what has happened over the course of a day or another period. It continues, diaries undertaken for institutional purposes play a role in many aspects of human civilization, including government records, business ledgers, and military records. So diaries are, or were and still are, very useful just to keep track of things, to know for future reference what has happened and why things happened. In our case, we want to keep track of code. We all write code, and we need to communicate to others how a piece of code was constructed and for what reason it was constructed. So there's a quote: "The primary goal of a software developer should be to communicate their intent to future developers." 9 out of 10, that future developer will be you. So you have to describe how you, in what state of mind you were when you got to this piece of code. And it's all about context. So you have to create some kind of context in your head to construct a piece of code. And even worse, or not worse, but later on, you will have to look at that code and you will have to build that context back in your head. So first you start with putting the lines in your head and you start interpreting the lines, what happens. So you come up with this very complex graph, which becomes even more complex, and then you have the complete state in mind of how something happens. So this is something that is not visible in the code, but you had to construct that in your head, and then inevitably, so your colleague comes and asks you something, and that complete context is gone, and you start again with the piece of code, and you have to construct that context. So with these two lines, you don't have a lot of context to build up why that code was there. So you have to start using documentation. You can use code documentation, you can use API documentation, you can put documentation in a wiki, whatever. And this talk focuses on using a version control system for keeping that documentation. So in a way, who's using a version control system? Git, Subversion, whatever. I think nowadays it doesn't make sense not using a version control system. So in a way, everybody is using a diary already. You might not be using it as a diary yet, but this talk is here to convert you into using it as a diary. So context. Re-establishing the context as a piece of a piece of code is wasteful. We can't avoid it completely, so our efforts should go to reducing it as much as possible. Commit messages can do exactly that, and as a result, a commit message shows whether a developer is a good collaborator. So it's not only for you that you are putting some code into version control, you are writing some extra context for other developers to see why something happened. So who's familiar with the Richardson maturity model? I think most of you are. It's just this graph of the holy grail of REST. So you start with level 1, the swamp of plain old XML, then you start using resources, you use the HTTP verbs, and then you go to level 3, hypermedia controls. So this is just more and more complex use of HTTP to end up with the holy grail of rest. This has nothing to do with this talk, but this is my commit maturity model, which I created to get more and more advanced in using commit messages, commits, how you build them, commit messages, and then the CLI and other tools that come with it. So every level will have, for all 3 parts, some explanation. We start with level 1, which is just Git basics, some Git internals. So here we go. So first of all, we have Git, but you have other version control systems. You have your local computer, which is you just organizing your file system, which is index.php, index1.php, indexfinal.php, indexfinal, so stuff like that. This is also some kind of versioning, but it's not very useful. The PHP Storm local history is also some kind of versioning, which is more useful. But this is on your local computer, and it's not really a version database. So we go to the next one, and this is a central version control system. In this category, we have Subversion, CVS, stuff like that. And in this system, the central VCS is keeping the complete version database. So in the days who used to work with Subversion, okay. So Subversion is just all the commit history is on the server. It's not on your computer. So if you want to commit something, you have to commit it to the server, and the server will say, okay, I got it. This is version 23 was checked in. And if you want to get a specific version, you have to reach out to the server, and the server will say, this is now the state the files were in on that version. So everything is centralized, which means that if we have merge conflicts, it's a whole other aspect in Subversion, and you have all kinds of locking, which distributed file systems kind of solve by using a better way of doing merges. So the next step is the decentralized version control system. And in this case, every computer has the complete version database. So if you look at a Git repository, you have the .git directory, and that has the complete version history in it. So in this scenario, the remote server is GitLab or GitHub, stuff like that, but you don't really need this. You can just, between 2 colleagues or anyone, you can push code back and forth, and everybody has the complete version control, the complete history on their computer. So Git is distributed. The way Git saves these versions. So this is an example of Subversion, and in Subversion, the server just keeps track of deltas. So you have 3 files, and the new version, you touch these 2 files, so you have some changes, and the computer or the server will keep track of the deltas. So if you want to have version 4 on your computer, the server will go back in time and then apply every patch. This is very useful for like binary files. If you have a lot of images, Subversion is very good at that because it will keep track of deltas and do some compression. But this is basically how Subversion worked. And Git, however, works with references. So here we have the same 3 files. And when we have version 2, these 2 files are the new version. And this is just a reference to the previous one. So at any given time in history, it just it has the correct files, and it doesn't use deltas, but it uses references to the previous version. You will need to keep this in mind for the rest of this presentation. And then we have the three different areas a Git repository has. So you have the .git directory. This is the complete repository. When you do checkout of the project, you get a specific version checked out in your working directory. So this is just next to the .git repository directory. And then we have the staging area. And most people don't realize this or use this as much, because if you do git commit -an, you're just skipping the staging part and you're just putting everything into your repository. The staging part is useful if you have changed 3 files, but you only want to commit 2 files, and you want to leave one in the working copy to commit in a different commit. Then you can add 2 files to the staging area and just commit the staging area. So this is also important to remember for the rest of this talk. And this is how the referencing in Git works. So here every version has a parent, and these are just flags also in the .git directory, which point to a given to a specific commit. So in this case, we have 2 branches, the master and the testing branch, and they both point to this to this version. And this is another flag, the head flag, which means the working copy is now the master branch. So if we do something, if we perform some changes, here we have changed to the testing branch, and we committed a new version. So here we can see that it has another, it points to this parent. So the history is starting to diverge. And here we go back to the master branch, we do another commit. So everything is now completely diverged, and everything points back to the previous commit. Also, to keep in mind for the rest of the presentation. So this is level 1, and in the REST example, you have the swamp of POCs. Here we have the swamp of plain old random commit messages, and this is something we want to avoid. So now we have level 1 completed, and this is not very good. So don't do this. All right, that was level 1. That was level 0. Let's go to level 1. If you want to start using Git in a good way, you have to make sure you're using atomic commits. And atomic commits are commits that are small and that focus on solving one problem at a time. So if you have a clean working copy and you want to change something on the login form, just focus on the login form. Don't mess around changing stuff on the footer and then putting that in the same commit. Just commit that separately. So you have atomic commits. For the commit messages, you have to say what and why you did something instead of how. If people want to know how you did something, they just open the diff and they see how you solved it. Most people, if they look at commit messages, they want to know why you did something. Use the subject and the body. So Git is a bit like emails. You have bodies. So you can commit something with a subject, and then if you do a new line, you have a complete body that you can fill with extra information. Only use it if it's necessary. Most of the time it is necessary, because in a small line you can't say everything you want to say. But if you change a typo, you don't have to include a reference to the dictionary in the body, stuff like that. People get it, it's a typo. You can just say fixed this typo. So use it only if it's necessary. So this is a small list of the 30 most frequent commit messages that are used on GitHub. For this list, they parsed 151 million commits, and they ignored all the merge commits. So this is from 2016. The highest one is initial commit. Who knows how that gets there? No, it's in the README file of, it's in the tutorial file of GitHub. So they say do git global your name and then do touch and do initial commit. So that's how it get end up there. So the following one is the update README file. So this is if you hit the pencil at on the GitHub page, then you do a change, and then at the bottom it shows you a subject and a body, and the subject is pre-filled with update file name. So everybody is changing that and just hitting submit. And then this one has to be a space because you can't create empty commit messages. So this has to be a space, and the rest is all useless. So update, dummy, fix, cleanup, test. This is not really helping. So make sure you're not using one of these in your commit history. So now that we have a lot of commits in our Git version database, we start using it, and we use it with git log. So if you do git log of a specific version, then you have the commit ID, who the author was when it was committed, and then you have the subject and the body. So very basic. Here you can see if you start digging back in history, you really want a good message describing what happened, so you can use it properly. So next is the -- grep. Here you can see that it's finding the keyword. It's somewhere here. Yeah. So it's finding the keywords in the subject or the body. So this is if you want to search for a specific ticket number, you can use the grep here, and then you see all the commits that were performed for that specific ticket number. And the next one is the uppercase S, and this one is very useful because this one is searching for this string in a deletion line or in a adding line. And here you can see that bcrypt was used. Almost can see it. It was used here. So this is very powerful. Imagine you clone a repository and you hit F5 and the browser says undefined method, I don't know. Then you just do git log uppercase S, I don't know, and you see when the lines where the method I don't know was introduced, and then you can read the message why an undefined method was used, or you can go to the author and ask why did you do something. So this is a very powerful option of git log. Okay, that's level 1. Everybody still who is using this kind of commit messages already? Excellent. All right, let's go to level 2. Here we start using pure atomic commit messages. So if you have if you change something and your PHP Storm editor adds a new line to the end of the file because you configured it that way, please don't commit those two in the same commit, because imagine you configured PHP Storm to delete all these spaces at the end of empty lines, and your colleague didn't do that. So you have a big file with all spaces at the end, and you change a typo and hit save, and then PHP Storm goes, all the spaces are gone, and then you do a commit, and then nobody will see what you actually changed because all the spaces were removed in the commit. So always do a separate commit for code formatting changes. And there are different ways of committing from a dirty workspace. And by a dirty workspace, I mean what I just said. If you have a file changed and there's a new line at the end of the line, you can not only, if you have 2 files that were changed, you can not only add one file to the staging area and commit that one. You can also add a specific section or a specific line of a changed file to the staging area. And you do that with git add patch. And you don't have to believe me. I will try to show you how you do that. So this is a small repository with two files. So if we change the index file and we okay, we add a line, and there's no new line here. There's no new line. We imagine the PHP storm added a new line. We have two changes in this file. And then we also update the README file. So just this, whatever. So if we now check what has changed here, we see that there's a change in one file, and there's a change in the other file, but there's also this new line sign that was added. So if I now commit everything, it will just include the new line, and we don't want that. So you can do git add -patch, and that will go over every chunk and give you a list of things that you could do. So it's quite obvious what you can do here. It's not. So you have to ask what you can do. So you have different options what you can do with this line. So we saw that there was a new line added, and we only we first want to commit that line. So here we can say that we don't want this line to be added. Here we see the new line, but we also see that it's in the same that's in the same chunk as the change that I did before. So let's have another look at the help. And here you can see that we can split the chunk into smaller parts. So if we split it here, we see that we get only that line, and we don't want that line either. So we say no, and now we say yes to the new line. And if we now have a look at how our workspace looks, we can see that the index file is both in the staging area and in the working copy. So if we now look at what we will commit, and here you can see only the new line is in the staging area. So, whoops. Oh, come on. Yes. Style. And if we now, oh, sorry. So I now messed that completely up, because by using the A, I take everything from the staging area and commit it. So this is wrong, but believe me, if I do just commit, it will only commit the staging area. So I actually have a slide which says don't use commit --am. All right, so this is just splitting up code to add it to the repository. But if you messed up somehow, there's also a way of rewriting history. So Git is distributed, which means part of it is private. So the things that you haven't pushed to a remote server are private, and it's very flexible. So you can rewrite history if you want. So there are two possible, or there are many ways, but the two things I will show are git commit --amend, which takes the previous commit and makes you change it. And there's also git rebase interactive, which allows you to change commits from minutes, days, whatever before. And this one, I also tried to do a demo. Okay, so I could indeed fix the previous one. I won't do that. I will start over again. So here we have an empty directory, and we will create a Git repository. I will add the README file. Yes, and I will add it, and then GitHub style. Oh, it's already added. Initial commit. I also have a slide. Don't do that. So if we have a look at the logs, we have the initial commit here, and now let's change something in the file. So readme, this line has a typo, and I will commit that one. Typo. So now I have a 2 commits, and they are a bit wrong. So I will use git commit amend, and now I can fix my typo. And then here you can see that this was the previous commit ID. And by using git commit amend, I rewrote history because the commit, the previous commit ID is not doesn't exist anymore. So we created a new commit. So this is all good. Let's add some more lines. Whatever. So this is a good commit. Yes. More lines. And now I have a look, and we have 3 commits, and here we have the typo. And if I want to finalize this, I have another review of what has happened. And I see that the second line here still has this typo. So what we do is we fix the typo, and we do something very annoying, which is a new commit stating fixing the typo, which is quite annoying because we don't want this useless commit. We actually want to rewrite the first. We want to rewrite this first typo commit so it doesn't contain a typo, and we want to remove that one. So if we now have a look at the history, like so, we have 4 commits, and I want to change this typo commit. I can now do git rebase interactive, and I say head, so this is the point where I'm at. I want to go back 3 commits. So now it shows me some kind of playbook, that I can run, and I can alter this. So this is the typo commit, and I want to edit this one. This one with the more lines is okay, and this one here I will fix with the edit part that I did before. So here I can drop this commit. So if I save this, it will start a interactive rebase where I can change things I want to change. So let's go. So here we see that we're at the stage that we want to edit. So we have some options we can do, but here I want to change the typo. So the rest of the content is gone because that is added later on. So here I fix the typo, and then I have to commit. I had to edit the file, and then I have to change. Then I have to change the commit because I changed the content. I added it to the staging, and here I'm now rewriting this part in my repository. So the typo was the commit message was okay. So now I rewrote that step, and here you can see that the commit ID also changed. So now I have a look at my options, and I can do git rebase continue, and it will play the rest of the playbook. So it will pick the next one, and it will drop the final one. So there's no interactive part anymore. So that kind of failed. Okay, so the reason why I added this many lines is because Git has some needs some more context to know how to place a diff, and because it didn't have that context at the top of the file, it created a merge conflict. So now I have to manually resolve this one, and then this. Okay. So here I have to add it again. Git commit amend. And if I now look at my, it felt horribly. So I should have this the last commit, but because I resolved the merge conflict wrong, my new commit is gone. So this works. Ask me later. I do it again, and then it will work. All right, demos. Moving on. So we want to write even better commit messages, and something you have to keep in mind is the length of a commit message. So keep it very short, because you don't want to have text that you can't read anymore, and that's falling off the slides. So a good guideline is 50 characters for the subject and the 72 character wrap for the body. So it fits on most command line screens, stuff like that. And then a very important one, stop using git commit minus AM, that should be. No, that should be dash M, because you want to use the body. If you use git commit minus M, you can only add the subject line, and you want to make use of the body. It's also have a side effect that some commit hooks are not executed. Because some commit hooks are attached to the editor booting up. So, but I have more on that later. So next is include a lot of references in your commit messages. Reference tickets, reference if you use some kind of pattern, just copy the link where you read about it, a blog post, whatever. Some manual page of a exotic PHP function you used. Just put as much references in the commit body that you want. And if you do so, use full URLs so people can actually click on the links, stuff like that, so they don't have to figure out where to go. So some examples why it's important to use short commit subjects is all these commands. You use the subject, only the subjects. So you want to have all the information in the subject, but you don't want to have it's too long, so you can't read it anymore. GitHub has a nice feature where if you type and you approach the 50 character limit, it has this pro tip which says that you have to put it in the body. So summarize it in the subject and add more content in the body. Okay, next up, graphs. Not those graphs, but the Git graphs. So they are much better, more fancy. So this graph shows all the commits and where they were on the different branches. So this is the minus graph and everything one line from Git itself. But if you use something like GitLab, you have a very nice view of what your repository is doing. So why am I mentioning the graph here is because by looking at the graph, you can see if you are using a decent branching strategy, if you are following some kind of beauty rules. So if your graph looks like this, here you can see master is running up here and everything, they're starting a branch, they're doing something, it goes back into master. So they are quite nice. There's another project which keeps pulling stuff from the remote server. So you see that the graph is like all pointing, all the lines are crossing. So if you have a graph like this, it's just a lot of noise and it's not very useful. So have a look at the graph and make sure everything is following nicely. And what you can see here are merge bubbles. A merge bubble is mostly a useless commit because it will add a commit every time you pull from a remote server. So if you search GitHub for this line, you will see 5 million commits that possibly could be avoided by using a decent branching, by using a decent pooling strategy. I recommend using git pull rebase instead of git pull, the default git pull, because this is a merging bubble which adds a useless commit here. So this is your line, and these two have to be merged somehow. So they do that by, this is a remote branch, and then they pull the branch and create a commit message. And if you do that by rebasing, you will store this commit in memory, and then you will create a new branch from the remote one. So this useless commit will be avoided. So rebasing more zoomed in, if we have this commit line, and here is master, and here is our feature branch, we have two options, because you want to use the code and master in your feature branch, and we have two options to get that code there. The easiest one is just to merge master into the feature branch, and then you create this new commit. But it's not very useful because it will scatter all the graphs in your Git repository, and it's again a useless commit that could be avoided when using rebasing. So what is rebasing? Rebasing is actually taking these three commits and like stashing them away, and then creating, instead of creating a branch here, we do a new checkout of master, we throw away the old branch, and we start a new branch from the latest master, and then the three commits that were stashed somewhere are just applied again on top of the branch. So this is a more clean way of getting your feature branch all the new code. A small word about squashing. Who is using squashing? Okay, I'm not a big fan of squashing because everything I thought in this talk is basically thrown away by squashing commits. So you start a new branch, and then you want that beautiful new code back into master, and you created 10 atomic commits, everything is nice, and then you put it back into the master branch, and then you squash all that beautiful commit message work into one big blob of code. Okay, so but that's why I'm not a big fan. So yeah, it's just the information is mostly lost. Okay, that was level 2. We're still with level 2. On to the final level. We had pure commit messages, now we'll have superb commit messages. So if you want to have a new commit message, you have to answer some basic questions. So why was this change necessary? How does it address the issue? What side effects does the change have? So you have to make sure that all these questions are kind of answered when you construct the commit message. The format is also very important. So this is some kind of meta commit, because this is Torvalds committing how you do a very good commit message while providing a very good commit message. So here you can see it has a subject, it has a body which contains of multiple paragraphs. You can have listings in it, and here you can use metadata. So this kind of has it all. Here you can use a ticket number, whatever. So include a lot of information in your commit. So here is another example of a very good commit message. If you have the subject, change default confirm target from 2 to 6. If you only do that, you can also see that when you open the div. But if you open the div, you only see like 6 on top of 2. It's not very useful. And here it goes on that they had an IRC meeting with a lot of ticket references in it. So this is a good summary of what you should include in the message. Your tickets, your commit message should be imperative. So use fix bug instead of fixed bug or fixes bug. We kind of agree on that format because git merge and git revert, they create commit messages on your behalf, and they also state it like this. So it says revert commit X instead of reverted commit. So everything is very it's always in the same way. And this you can a nice trick is if applied this commit will and then fix bug whatever, or so if you add that line before your commit message, it's very clear what will happen. And also whoever used git revert, if you do git revert and a commit message commit ID, it will create revert commit and then the commit ID. And if I like fix a bug and I see where and which commit ID it was introduced, I usually include that commit ID too, because it's very easy if you use like GitLab or GitHub, that you can just click on that commit ID and go straight to the commit. So if it's possible, add that one too. Some power commits, you can use hooks to automate stuff. So you could use hooks to close issues in commit messages. So if you have some kind of format, fix bug, whatever, that your remote server could understand. If you not use git commit -m, you could have some kind of script that the moment you do git commit, that reads the branch, and if you use like bug fix / the bug ID, it could prepend that number in your commit message, so it's always in the same format. So you can even use it to validate message formats. So does it include a bug number? Is it in the imperative form? If that's even possible. And also, I tend to also always include issue numbers. But if you use GitHub, it's not that nice, because every commit that you do with a git with an issue number and you push it, it will add tons of links and comments and the issues. So it depends on what system you use, but I normally use it because if you're out of the development phase and you're in the maintenance mode and you're committing without an issue number, you're doing work that's not supposed to be done because there's not an issue for it, maybe. So now every line of code is actually always documented. If you use git blame, you can see for every line when it was committed, what commit ID it was. So if something went wrong, just do git blame on a specific file and you see everything, what has happened. If something good happened, you also have to use git blame, which kind of sucks. So add this alias. So if you see some good code, do git praise and then the commit, then the file, and you see, oh, this beautiful piece of code. All right, in summary. If you use some kind of message format, just use it per project, per company, whatever. But document it. Document how the style, what the style of the commit should be, what it should include, what metadata it should include. So just have some kind of documentation stating how it should be done, so everybody is on the same file. Ditch GUIs and start using the command line, because like the git add interactive and git add patch is so powerful that most GUIs can't really visualize that. So use the command line. Before you commit, read your code, and if it's necessary, if you do before you commit, do git diff, and then you see everything that's going to be committed. If it's necessary, just do git add -p and only add sections of it, so you can split up different commits. Don't do end of the days git commits. Yeah, so you're hacking away all day and then git backup and then push it to the remote server. Don't do that. Check your impact on the commit graph. So the impact, I mean, how do you commit? How do you merge? How do you rebase? How do you squash? Stuff like that. And if it's necessary, rewrite history. It's possible. Git is flexible enough. And that concludes the talk. Thank you very much.